Hi friends, welcome back. Here we are with the independent practice exercise for chapter 1.1, representing rational numbers on a number line from Math in Focus, Singapore Math Student Edition, Course 2A. I'm sure you had an opportunity to go through the concepts of this chapter in another video. It is important that you go through it so that your concepts are clear and you can solve this exercise easily. You will understand what we are doing over here. Okay, and for my rough work I'll be using a separate paper rather than doing all my rough work over here. Okay, even you can do the same in your exams, in your practice, so that your paper, your practice looks neat and clean. Okay, so let's begin with the first part. It says find the absolute value of each fraction. Okay, so we are asked absolute value. Okay, and you know that absolute value is always positive, right? Draw a number line to show how far the fraction is from zero. Write each fraction in simplest form. So you have to find the absolute value, you have to draw a number line and write each fraction in its simplest form. Okay, you remember when we say simplest form, we have to simplify it until there is no possibility for further reduction. Okay, so these are the three things we have to do in this first part. So we know when first is 7/10. We know when any number is divided by 10, you just it's like, say for example, number is 8 and 10, it's 1 0, right? So you start counting the number of digits from right to left. It's 1 0, so you count to 1. So 1, and you put a dot here, the decimal point, right? So for example, it was 80 over 100, so this gets cancelled, so it's 8. Or if you do it the same method as here, so 80 you write as it is, and how many zeros? 1, so you put here, you counted 1 from here, right? So this is how you usually do when numbers are to be divided by 10, 100, something like that. Okay, so this will be 0.7, right? Then we have 18 over 8. So let's just do the calculations here. 18 divided by 8, right? So 2 times 16, the remainder is 2. You put 0 and you put your decimal point here, right? So 8 times 2 gives us 16. Remainder is 4. You put another 0. Now no need to put decimal point. We already have it, right? 8 times 5 is 40, and this is 0. So this is even a terminating one, right? So this is 2.25. Okay, when we are asked to find the absolute value, we put within this, right? So all of our answers will be positive. Then the next number you have is 5 divided by 13. Okay, so you know 5 is smaller than 13, right? So this is not possible directly. So you put 0, right? And you put here decimal point. 13 times 3 is 39. Remember, you need to know your times tables. It's very important that you know it. Okay, so next one is this 11, and then you put 0 here. Now, how do you solve this further unless you know the times table, right? So this number, the other way, you can use some smart tricks. 13 times 10 is 130, right? And this is 110. So the difference is of 20. So 13 times 9 will not also work. So 13 times 8, let's try that. You know what is 13 times 8, right? Do you know it or you don't? If you don't know, let's just do it here quickly. 13 times 8. 3 times 8 is 24. 2 carried forward. 8 times 1 is 8. Plus 2, 104. Okay, so it's 8 times 104, 6. Then you go on. But we'll just take up to 2 digits, okay? Because we need to put them on the number line, right? So though this is here negative, right? So our absolute value will be 0.38. It will not be negative, right? This is 8. Then the next number is 48 divided by 15, right? So this is 3 times 15 times 3 is 45. Remainder is 0. You put 0 here. Sorry, remainder is 3. You put 0 and a decimal point here. And 15 times 2 is 30. Terminating, right? So this is absolute value we are talking about. And this will be 3.2. Okay, so these are our four values: 0.7, 2.25, 0.38, and 3.2. Now we have to plot it on a number line. So let's get our scale and the pencil. Now I will analyze my numbers. The smallest number I have is 0.38 and the largest I have is 3.2, right? So I don't need to have a long number line. Rather, I will use the units. I'll make the centimeters that I take for each unit. I'll enlarge that, okay? So let's say we start from here, okay? So this is my 0. Instead of saying 1 centimeter as my 1 unit, I'll take 2 centimeters as my 1 unit, okay? So this will be 1, 2, 3, and this will be 4. So let's mark it. Okay, let me just turn my page. And here we are on the number line. Okay. It's absolute value, right? So we're not plotting negative values here, okay? So let's say this is 0. This is 1, 2, 3, and 4. Now 0.7. So as you can see, like 2 centimeters is taken as 1 unit, right? So each tiny 2 units here, this one, okay, we're talking about these 2 points, will represent 0.01. So we have 0.7. So we are going, means 1 unit is like 1 centimeter, 1 unit is 2 centimeters here, right? So each time we plot this, you have to double it up. 1 unit, 2 centimeters. So it's a double, right? So all this will be doubled. So that's how you will mark on the number line. So 0.7, the double is 1.4, right? So we will mark between this and this 1.40. This is 1 and this is 1.5, right? So here is our 1.4. So this is 0.7. Okay. Next is 2.25. So if you double it, it actually becomes 4.5. So this 2.25. Okay, so we need to, we are okay here, 4.5, right? So 4 is here and this is 4.5. Okay, these are the 2 points. Then 0.38, right? So it's basically approximately 4. So we go to 8, right? So here we are and we need to mark around 8. So we'll go around 7, okay? So between 7 and 8. So this is 7 and this is 8. So I'll mark somewhere between here. So this is 0.38, right? And then you have 3.2. Okay, that's my bad. We said we are doubling it up, right? So this is 3.2. We need to go further, which is 6.4. So no worries, we'll extend the line. Okay, we extend the line. Here, this is my 5. I go further. This is my 5. This is my 6. And this is my 7. Okay, this is 5. This is 6. This is 7. Okay, so 3.2, right? It's basically 6.4 if we double it. As we said, we added, it has to be between 6 and 7, right? So 6.4 will be marking here. So I hope you're understanding, okay? We are not doubling here. It's each unit, 2 units represent 1, right? So I'm taking 4 units. That's why I said 6.4. So this is 3.2. Okay, so each one is doubled up. just to this looks better, neat and clean. Otherwise it becomes clumsy. If you want to take 1 unit as 1 centimeter, you can do that also. Okay, but for cleanliness, for neatness, I've done this. There's no harm in taking 1 unit as 1 centimeter as you feel comfortable, because sometimes these calculations, if you forget to double up, you might end up making a mistake, right? So be careful. Okay, so sometimes you see me making some mistakes. It's not that I'm making mistakes, I'm just doing that so that I can caution you, right? So I doubled this up, I doubled this up, I doubled this up. Then here I did not double, I did not do the calculation, I did only until 4, right? So this wouldn't fit. I was taking that as 3.2, whereas I should have taken it as 6.4. Okay, so pay attention to even those mistakes that I'm committing purposely, because these are the mistakes that we end up actually doing while solving. So when you double up, be careful. Okay, now next what we have is write each integer or fraction as m over n in simplest form. Simplest form, right? No further divisibility possible. So then we have where m and m are the integers. So let's get going. You remember from our previous video where we understood concepts, when we want any integer like this as this format, you simply divide it by 1, right? Okay, so this becomes 67 over 1. And in the simplest form, we can't divide this further, right? Okay, we can, so it's going to be 67 only. Next, we have 340 minus 345. So what will we do? Just write over 1 and leave it as it is. Okay, now we have this one in the simplest form, right? So 25 over 80. So we know 25 is 5 times 5, right? So we write the factors over here. And 80, what are the factors? You can go like 2 times 2 times 2 times, like 80. Like you can do this process here. Let me show it to you here. 80, 2, 40, 2, 20, 2. You know what I'm doing, right? Dividing. 2, 5, 5, 1, right? 2 times 40, 80, 2 times 20, 40, 2 times 10, 20, 2 times 5, 10, 5 times 1, 5. So the factors would be 2 times 2 times 2, all of this. But if you look at this number here, okay, it's 5 times 5, right? And if you know your times tables, rather than doing all this work, you could simply write 5 times 16, because anyways, those 2's that you have here, if you do this also, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, right? And those 2's will not cancel here with the numerator. So you can directly write 5 times 16. You don't need to have all the prime factors here. Okay, so we cancel the common factor, 5 and 5. Okay, and so what are you left with? 5 over 16, the simplest form. Okay, so that's how we do it. Next we have is 264 over 90, and that's a minus 1. Now it's a big number. You can use this rough paper to get the prime factors, right? So let's do it here. 264 ends with 4, right? So we will divide by 2. The divisibility for test for 2 is even number. The last digit has to be even number, right? So 2 times 1 is 2, 2 times 3 is 6, 2 times 2 is 4. Okay, again we divide by 2. So now with 1 it's not divisible, so we take 2 digits, right? So 2 times 6 is 12. This is 13, so we have 1 here, and 12 right now. So 2 times 6 is 12. Then 2, 33. It's easy, right? 3, 3. 3, 11 times 11, 1. Okay, so let's write these factors over here. The factors that we have, they are 2 times 2 times 2 times 3 times 11 over 90. Now 90, let's try and do orally rather than doing it here. Okay, 90, we know it's 2 times 45, right? So we write 2. 45 can be further divided. 45 is 3 times 15. So we write 3. 15, it's further divisible, right? 15 is 3 times 5. So this is the way that you can do it mentally, orally, okay? Provided you know your tables very well. We start cancelling the common terms here now, okay? So let me do the cancellation with pencil. That's how I prefer, and that's how my teachers have taught me. 2 gets cancelled, right? 3 and 3 gets cancelled here. So what are we left with? 2, 2 and 11. 2 times 2 is 4. 4 times 11 is 44. And 3 times 5 is 15. And this is a minus fraction, right? We are not asked for absolute value, so we'll put the minus sign as well. Next we have is 14 over 70. If you know your terms table, as I've been always saying, 14 times 5 gives you 70. If you do not know directly, both numbers have 7, right? So 7 times 2 is 7 times 10. One of the ways as I would directly do is, this is 1 times and this is 5 times, and I get minus 1 by 5. Or if you do not know 14 table, but you know both has 7, right? So 2 times 7, and this is 7 times 2 times 5, right? 7 times 10, so 10 is 2 times 5. 7 gets cancelled, 2 gets cancelled, and you're left with 1 over 5. Okay? Next is 600. Do you want to do it orally? A big number, right? But this big number should not scare you because both the numbers end with 0. So whenever you have such situation, cancel them directly. This 0 and this 0 at the end, okay? Not in the middle, the last one. Because this is basically 60 times 10, right? And this is 48 times 10. So actually getting rid of this 10 over there. So that way you make your number smaller. Okay? So now this number has actually become 60 over 48, right? And this number should click immediately. What is it? So this both has 6 in common, 6 times 10 and 6 times 8. So 6 is what? 2 times. I will not further divide 6 because I know 6 will get easily cancelled here, okay? 6 times something and this is 6 times something, right? Now 10 is 2 times 5 and 8 is 2 times 4. I could go 2 times 2. I'm not doing that because I don't have any possibility to cancel. Okay? So this, if you had factorized, it would be 2 times 30 first, right? So this would further go on and becomes 2 times 2 times 15. Then this is actually 2 times 2 times 3 times 5. And this is how you would end up writing. So this is actually 6. So 2, 6, 5. You have it here. Okay, rather than going this route, find the common thing that practice, and those things will easily click to you and you will do maths much faster. So we cancel 6, 6, we cancel this, we cancel this. And what are we left with? 5 over 4. Okay? So this is how you solve this part. And we are already done with 10 sums over here. I'm sure you're finding it easy. And as I always say, practice, 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 and you will do much better job at it. Okay? Now what do we have next? We are asked that mixed numbers, you know, formula AC plus B over C. Okay, this formula, you have to use this formula and solve everything. So let's get started. So first one we have is 7 over 9, right? So this is A, this is B, this is C, you know that. I'll just do this once, rest you know. I mean, I won't be writing A, B, C each time, okay? So 7 times 9 plus 7 over 9, right? Which is equal to 7 times 9 is 63 board mass, right? So you do your multiplication first, not the addition, right? Plus 7 over 9, right? Which is 70 over 9. That's it. Done? Okay. We go to the next one, A, B, C, right? So now this is a minus sign. So minus 5 times 10, okay, plus 1 over 10, which is equal to 5 times 10 is 50. So this is minus 50 plus 1 over 10, right? If you do this, you will get minus 49 plus minus 50 plus 1, right, over 10. And this is wrong. Okay, this is wrong. This minus sign is applicable to the whole thing. It's not just for the minus one. Okay, so let that minus, let's just solve it, and at the end we put the minus sign. So this is 5 times 10 plus 1 over 10. This, okay, and this is 50 plus 1 over 10, which is equal to 51 over 10, and this becomes minus. Okay, so be careful. If you just take this minus 5 like this, you will end up having a wrong answer. Okay, then we move to the next part, which is 2 5 over 12, right? So this is 2 times 12 plus 5 over 12, right? 2 times 12 is 24 plus 5 over 12, which is equal to 24 plus 5 is 29 over 12. Okay, then we have this number minus sign. Be careful, let's not get into this trap, right? So this will be 10 times 36 plus 11 over 36. AC plus B over C, which is 10 times 36 is 360 plus 11 over 36, right? Which is equal to 371 over 36. And remember the minus sign. So if you want, you can actually do this each time so that you don't forget your minus sign. Okay, so let's move to the next part. I have my other paper here. Okay, so this is the next. We have 0.4. Now how do we do 0.4? Do you remember? We need to get m over n format, right? Decimals. How many digits do you have after a decimal point here? It's 1 digit, right? So you will say 4 over 10, 1 0, right? 1 digit, so you put 1 0. And then we are supposed to get it in the simplest form, right? So we need to solve this further. So 4 over 10. We know this is 2 times 2, and this is 2 times 5, right? So we cancel 2 and 2, and we are left with 2 over 5. Okay, so if you divide 2 by 5, I will just show you here. Okay, so say 2 divided by 5. Okay, so this is not directly divisible, right? So we put 0 here and a decimal point here. 5 times 4 gives us 20, and this is 0.4. Okay, just a way to confirm that you have done your answer right. Now let's write 625 minus, now how many digits do we have? 1 2 3. So after 1, how many digits do we put? 1 2 3. Okay, now this is further divisible, so we will do that. So 625, this is actually 125 times 5. Okay, so 5 times 125. 125 is again 5 times 25, and 25 is 5 times 5. Did you get what I tried to do? 5 times 5 is 25. 25 times 5 is 125. 120 times 125 times 5 is 625. Okay, so you go this route, or you have this simple other option. 5 1 1 carried, right? That's 2 carried, right? And this is 5. I said 5 times 125, right, when I started. Then again 5 2 times 2 carried, this is 5, right? 5 times 5, 25, and this is what you have here. Okay, similarly for the 1,000, 1,000 is 2 times 500. Okay, so 2 times now 500. You further divide that. Is that helping you, or do you want me to do it here? I think I'll do it here so that it's clear. I don't create confusion. Okay, this is how I would do 1,000. 2, 500. 2 times 250, right? 2 times 125. Yeah, now this ends with 5, right? So again 125. So if you don't want to do, you take this 3 digits now from here. Okay, the same process would come here, right? So this is 3 times 2 we have, right? So here 2 times 2 times 2 times 5 times 5 times 5, right? From here. So we'll start cancelling the common digits that we have. So we have 3 5s here, right? And 3 5s here. So this cancel. So what are we left with? 1 5 in numerator, right? And you have what are 2 times 2 times 2, that is 8. Okay, so this is the answer. Okay, next we have is 5.80. So we write 580, right, as we said with the decimal. How many digits did we have after decimal point? 2. So 1 0 0. Okay, again, now we will cancel 0 directly, right, so that our life is easier. So this is actually 58 over 10, right? So if you do this directly, 58 over 10, you'll get this answer. Okay, so 58 is what? 2 times 29, and this is 2 times 5. 2 cancel, so it's 29 over 5. And if you actually divide it here like this, 29 divided by 5. Okay, 5 times 25, right? Remainder is 4. Not possible, right? So you put 0 here and a decimal point here. 5 times 8 gives us 40. Okay, so just a way to cross verify. Now next what we have is 9001. I'll write all this. How many digits you have after decimal point? 3 digits, right? So 1 and then 3 zeros. This is not, there's no common factors here, okay? So we'll just leave it as it is. Then what we have is minus 10. Remember the minus sign here. We missed on the minus sign. 10.68. So I'll write this as 10 and then 68. 1068, right? 2 digits. 1 0 0. Okay. You start factorizing it now. 1068. I need a fresh page now. 1068. 2 times 5. 2 times 5, right? 10. Then 2 times 3 and 2 times 4, right? Then it ends with 4, so we again divide by 2. 2 times 2 is 4, 1 carried forward. 6 times is 12, 1 carried forward, and this is 7. Okay, so now 2 plus 6 is 8. 2 plus 6 plus 7, right? So this is 8 plus 7, which is 15. 15 comes in 3's table, right? So we divide it by 3. 3 times 8 gives us 24, right? So 2 carried forward, 3 times 9. Now 89 is a prime number, okay? So this is 89 and 1. So the factors are 2 times 2 times 3 times 89 over 100. Okay, so 100 is 2 times 50, right? Now I'm just doing the other way, faster way, rather than doing all these things. 2 times 50 gives me 100, which is this 2 times 50 is 2 times 25. So this is 2 times 2 times 5 times 5. right? 2 times 2 is 4, 4 times 5 is 20, 20 times 5 is 100. So 2 times 2 times 5 times 5. Now let me cancel the common factors. 2, 2, 2, 2, cancel, right? So what are we left with is 3 times 89. So 3 times 89, you don't have to again do it here, okay? You can like, okay, 89 times 3. You can, from this, you can say this is 267. So this is 267 over. This is 5 times 5, right? Which is 25. Okay, so this is the answer that we have. So I hope this is getting clearer, easier, and it's helping you. And you try and do some sums by yourself before going further to the on video and see if you can manage it. And if you can, it's amazing. Okay. So next what we have is locate rational numbers on a number line. We just have to put them on a number line. Okay. So let's first get them in the decimal points or the normal, get rid of the fractions that we have. 1 divided by 4. So these are fractions that you should know by heart. What does this result into, right? So this is 0.25. Okay, if you don't know, you can go divide. If 1 divided by 4, you 0 decimal. 2 times 8, 205, right? It's like basically, it's like you have one chocolate, you divide into 4 parts, you know, each one is going to get a quarter, right? So this is it. Then this is already in the fraction format. This is fraction 5 divided by 2. It's 2.5, right? Okay, so we got to plot this on a number line. So we have 2 negative numbers and 2 positive numbers. Now how are we doing to, how are we having the number line? What numbers are we going to take? Now you have from minus 1.5 to 2.5. So do you just want to take 1 unit as 1 centimeter? You can do that and make your life easy. Okay, so let's just go this way. So let's say this is minus 2, minus 1, 0, 1, and 2, and 3. Okay, so minus 2, minus 1, 0, sorry, this is plus 1, 2, and 3. 0.25 minus, right? So this here between 0 and 1. So now we know each tiny point, each point between this 1 centimeter represents 0.1, right? So this is 0.25. So between 2 and 3 we will mark it. This is 3, this is 2, so we'll mark in between here. Okay, so this is 0.25 minus. Okay, then we have 1.5 minus, right? So this is 1 and 2, and this is easy to mark because it's 0.5. We have it here. Okay, I will write this answer here. I don't want to make it clumsy over here. Okay, then it says 0.8 from here and here. So if 5 is this middle one, right? 6, 7, 8. So it is here. This is 0.8. Then I need 2.5. Easy to mark because it's 0.5. So the middle one, because if you see the middle ones are also marked on the scale, right? So this is it, 2.5. So this is how you put them on a number line. Okay, it's simple, right? So let's continue. Next one, it says graph each one on a separate number line, which means you have to draw a number line for each one of this. Okay, so let's first convert all of them into a decimal format, and then we'll plot each one of them on a number line. Here you could go like AC plus B over C, but remember there's this E. Rather than doing that and making your calculation stuff, let's just divide 1 by 8. Okay, so let's get our rough paper. No, I guess I have enough space here. So 1 divided by 8. Okay, nowadays actually in this course we used to draw a line here at the end, making it as a rough work. So we'll do this one, okay? 1 over 8, we are doing this one. 67 will be as it is, 1 over 8. So 1, it's not directly divisible, right? 0, so point, 1 times 8, okay? 2, remainder, 0, 6, 8 2s are 16, 4 is the remainder, 0, 5, right? And it terminates here. So what will be the answer? Our answer will be 67.125. Okay, so we take this 0.125 and we add it here and we put it like this. Okay, then you have 305 divided by 20. Now 305 is actually 5 times 61, and this is 5 times 4. Okay, so because see, 5 times 6 gives me 300, right? This is how you do fast maths. Rather than doing everything, what you do, 5 times 6 is 30, I know. So 5 times 60 will be 300, right? You added 0, you add 0 here. Now 5 times 1 is 5, right? If you add this, this is 305. When you add this, this is 61. So it's basically 5 times 61. Okay, so now we cancel the common terms that we have. So this is 61 over 4. And we divide that here. 61 divided by 4. If this is actually going to be 15 point something, because 4 times, so rather than going like, okay, 1 times 4, I'll say 15 times directly, okay? 61, 0, I have a decimal point here. 2 times is 8, then 2, 0, 5. Did you understand what I did? I'll repeat myself, okay? So this is basically 61 divided by 4, right? One way that we generally do is say, okay, 1 times 4, like this, and then say 2, and then 1, and then we go on like this, right? So instead of what I did was 61, my 4 is here, and I know my times tables, right? So I know 4 times 15 is 60. So I directly did that and have 1 here left, okay? And then the normal 1 I did. So that's the way to go faster. So this is basically 15.25. Then we have is 98 over 28. Okay, so 98. This is actually double of 49, right? 49, right? 49 plus 1 gives 50. 98 plus 2 is 100. So I'm just doubling it. There was a difference of 1 to reach 50. When I doubled up, the difference should be 2. Okay, so this is 2 times 7 times 7 basically. And this is 2 times 2 times 7, right? 2 2s are 4. 4 times 7 is 28. Okay, so I'll cancel the common factors again here. So my 2 gets cancelled, 7 gets cancelled here. So what are we left with is 7 over 2, which is actually 3.5. 3 times 2 is 6, right? 0.5 times 2 is 1. 6 plus 1, 7. Okay, so it's like a number between 6 and 8, right? The double of 3 is 6, double of 4 is 8. So difference is of 2. So that's how you do that way. These are just some tricks that I will keep sharing so that you master math, okay? We just don't keep solving, but we understand, we remember, and we try to be faster. Next is minus 21 over 12. You know 21, right? So this is basically 3 times 7. And this is 3 times 4. I will not write 2 times 2 here because there's no possibility to cancel, right? 3 cancel. So this is minus 7 over 4. You had 7 over 2, which was 3.5, right? Now this is minus 7 over 4, doubled. 2 has become 4. So this will be half, right? So this will be 1.75 and minus. Okay, half of 3.5. Half of 3 is 1.5, right? And then 0.5 is 0.25 half. So I have 1.75 over here. Okay, this is just some way to get faster over it. So let's now put them on a number line. Okay, so what we have here is 67.125. So how are we going to put it on a number line? So I will have an, okay, I will have my 0 over here, and in the center I'm going to make this mark indicating that there are possible digits over here, okay, because I cannot show each one on here, 1 2 3 4 like that. So I just do this, and I'm here marking my 67. Okay, then from 67, if I go on each centimeter, now each centimeter I'm taking as 1 unit. Okay, likewise I go on, so this becomes 67.1. okay, this becomes 67.2, and likewise, yeah, I have 67.125. So this is 1 and this is 2, right? So it's between this. I have 10 units now, right? 67.1 is done. So I need 0.25 in a way, 0.025, right? So each one here represents, so this is 2 and 3. So I'm going to put it between 2 and 3. So this is 67.125. Okay, so this is how I do it on my number line, rather than going each unit like as centimeters, 1 2 3 4. I'm just putting it, getting it closer to what I want. Okay, and this is what we can do. Next we have is 15.25. So again we go in the number line, and the same thing I'll do. So I have my number line here. Let's say I will do this here, and I'll extend it further. So this is my 0 here. Okay, so I will mark my 15 over here. So this is 15.1, 15.2, 15.3, 15.4. Okay, 15, 15.1, 15.2, 15.3, and we want a number, but it's 2.5, right? So 2 and 3. So it's the middle number here. So I mark this centimeter here, and this is my 15.25. Okay, so this is how I would do on a number line. Okay, and as we have said, take this what is convenient for you and easier for you. Okay, and don't just plot all the numbers like which are not required. Plot what is needed and make it neat and clean. Now what you have next is 3.5, right? So how are we going to do that? So I can actually take normally, this is my 0 1 2 3 4 and 3.5, right? So this is where my number will be, 3.5. I actually plotted my number first so that I don't have to take the scale again and do it. I know it's in the center, right? 3.5, 3 and 4. So that way you save your time and you go faster. 1 2 3 4. That's it, and you're done. Next, what you have is 1.75. Okay, so we plot it here. Let's say this is 1, this is 2. So this is easier. 7 is here between 7 and 8. I just did simply 1. This was my 0 extended. This is 2, and this is 1 point. Okay, we're making a mistake here. What mistake are we making? Yes, it's a negative number, right? So what are we going to do? What are we going to do? This is gone. So let's do it again here. So this is something that you would end up doing in exam, okay? Or while you're practicing if you miss on the negative sign. So remember, mistakes are done to learn, to teach you something. So let's start from this side, okay? So my 0 is here, 1 is here, 2 is here, right? And I want 7, 5, so 5, 6, 7, between 7 and 8. So this is minus 1.75, right? This is minus 1, this is minus 2, this is 0, and this is how we would do it. Okay, I hope this is clear, easier. Remember to take units that work better for you. Okay, so we go to the next part. We still have 2 problems here for the same category, so let's get going with those 2 also. So minus 25.8. Okay, how are we going to do this now? Already we have it in the form of a decimal number, right? So we just simply have to plot this now. So I will start from here, my 0. Okay, let me just take these papers out so that they don't disturb us. And here we are. Let's start here. We go this way. This is my 0, and I'm going to leave a gap, and I'll start from here with minus 25. Okay, 25.1, 25.2, 25.3, 25.4, 25.5, 6. I go further. Let me go further here. 7, 8. Okay, so there's 25 exactly. Okay, minus 25, right? And we will do this mark here. So this one is minus 25.1. This I'm going to write up and down just to avoid making it clumsy. Minus 25.2, minus 25.3. This is minus 25.4. This is minus 25.5. This is minus 25.6, minus 25.7, and this is minus 25.8, right? And this is the number that we want. Okay, so that's how I'm plotting it here. Then we have 45.3, and this is a minus 1. Okay, so we will be going to the left, right? So let's say this is my 45, this is 45.1, 2, and 3. This will be 4. Okay, so 45.3 minus, this is what I want, minus 45.2 minus 45.1 minus 45.0, and we go this route and mark 0 here. Okay, so indicating that there are numbers in between, right? So this is how I would plot all my numbers on a number line. Okay, now we are on the last part of the chapter, the independent practice exercise, and let's see how to do this. So let's first read the question. It says, a video game gives you 10 minutes to find some treasure. Do you play video games? You do, I'm sure. You enjoy it, right? The numbers below show the amount of time left when you have found the treasure for each of 8 games. Okay, so we have 8 games. I'm sure when you play 8 games doesn't suffice you, right? A negative time means you have gone beyond 10 minutes. Okay, each number that you have negative here, which means you've gone beyond 10 minutes, and you're actually given 10 minutes to find the treasure. So if you go beyond that, you're finding it after. So that's why it's given negative number. Use this data to answer A to H. Okay, so these are the numbers that we have. So positive, which means you have found before 10 minutes, 0, exact 10 minutes. Negative, you have gone beyond time. Positive, this is basically, it says the numbers below show the amount of time left. Okay, so if you have 6 here, actually you found it in 4 minutes, right? So 6, this is negative, beyond 10 minutes. 8, time left, so basically you did it in 2 minutes. Amazing. And 7.8 and minus 9.1. Okay, so what are we supposed to do here? First, order the times from most to least time left using. So the time left, okay, and you have to use this symbol. Always try and mark the important points, like important words, that helps you answer it easily. So for us to do this, first and the foremost, we need all these numbers in the same format, okay? So let's try and convert these numbers first. So 23 by 8. Let's divide it here, okay? So 23 divided by 8, right? So 2 times is 16. 8 times 2 is 16. You're left with 7, 0. Now we're putting 0, right? So we'll put a decimal point here. So this is 8 times 8 gives us 64. You're left with 6. We put again 0. 7 times 56. 4. We put 0. We put 5 here. And this is how you would solve it, right? So this is 2.875. This is the time left, okay? 0, you don't need to do anything. Then let's convert this one. So this is 7 times 5, right? A times C plus B over C, right? So this is 7 times 5 is 35 plus 1 over 5, which is 36 over 5. And this is our negative number, right? 6, we don't need to do anything. This is 36 over 5. So what are we supposed to do? Is that it? Now we need in this decimal format, right? So we will divide this. So how do we do it? So this is 36 divided by 5. Okay, so this is 7 times is 35. Are left with 1. So do you see this? 7. This quotient is here, okay? This remainder is here. And this divisor is here. Okay? Then you put 0, decimal, 2 times 10, done, right? So if you do this root, the other root was simple, like you just take the 7 as it is, okay? And 1 divided by 5 is 0.2. So this was the other way of solving it, 7.2. Okay, 6 we don't do anything. 17 over 4. Let's solve that. 17 over 4, right? 17 divided by 4 basically. So 4 times 4 is 16. 1, right? We put 0 and we put a decimal point here. 2 times is 8, right? 2, we put 0. 4 times 5 gives us 20. So this is 4.25. So this comes here. This is minus, okay, 4.25. Rest are all in decimal format, okay? So only 3 we had to convert, right? And we have done that. Now we are asked to order the times from most to least time left. Again, this all are the time left, right? From most time left. So of course your positives will come first because negative means you have already gone beyond 10 minutes, okay? So let's start arranging them. So what are the numbers that we have here? If you say these are the times left, right? So this is 2.875. Let's put all the positive numbers here. 2.875. I'll not put 0. I'll put 0 here separately. This is negative. Then I have 6 as a positive. This is negative. Then 8 as a positive. Then 7.8 as the positive. So I'm putting all my positive numbers here first, okay? Then I have my negatives here. I'm just making my life easier. Okay, then 0. All my negatives I'll put here. Minus 7, so the 7, 1 over 5 is actually minus 7.2, right? Then I have one more negative here, which is minus 4.25. This one 17 over 4, right? So let's see, how many numbers do we have? It says 8 games. Do we have all the numbers? 1, 2, 3, 4, 5, 6, 7, 8. I'm missing one number here. What am I missing? Oh, minus 9.1. This is here. Okay, so these are my negative numbers. These are my positive and this is 0. So these are my 8 numbers, all arranged, sorted and categorized. Okay, so order the times from most to least time left. Okay, so first we'll go with the positive numbers, right? So the greatest one is 8, which is greater than. Okay, I'm done. 7.8, right, which is greater than. This one is done. 6. This, and the next one greater than. 2.875. Okay, now I'm not going to do my 0 and the negative numbers. Okay, if I wanted to arrange, I can go, but it says time left, from most to least time left, whereas we know negative numbers, here it directly says you've gone beyond 10 minutes and each game was giving you 10 minutes, right? So I'm going beyond, so there's no time left. I'm over using the time. I'm going beyond the allotted time. So I'm going to put my negative numbers here. Okay, so this is it. I will not even put 0 because there's no time left, right? 0 means 0 minutes are left. I've already used 10 minutes. Okay, so this is how I would solve this. Then it says write the absolute value of each number, right? So 23 over 8. You just have to write the positive values. So we write 2.875. 0 remains as it is. That's minus, right? Minus 7. 1 over 5 is minus 7.2, which is 7.2. Right, so I actually don't need to do all this because you know that you just have to put them in this like minus 9.1, right, in its absolute value format between these two lines, and then you say 9.1. So you just have to do this for all the values that you have here. Okay, now it says which number has the greatest absolute value. Okay, so I have all my numbers here, right? Now forget these are negative numbers because we're talking absolute value. So which is the largest number here? It's 9.1, right? So greatest absolute value. So the sign doesn't matter. We're talking about the distance. It is 9.1, right? Okay. Then it says order the values from least to greatest, from the smallest to the largest. Okay. You have to order them from the smallest to the largest, but you're putting the absolute values. Okay, so all this negative and positive, we're going to treat them together, and this will start with 0, right? We'll start with 0, and then 0 is less than. Now from these, which is the smallest one? 2.875, which is the value of 23 over 8, right? 23 over 8 less than. So I'll just keep cancelling the ones that I'm done. I'm done with 0. I'm done with this. Please use pencil so that you're not confused. Okay. Then the next one, 6, 8, 7.8, 7.2, 4.25, 9.1. So 4.25. Okay, which is the answer for 17 over 4, right? So I'll put this 17 over 4, right? Okay, then I have this is done. Then I have 6 and 8. 6, then two values with 7 point, and then 8 and 9. So I'll put them here. So 6 is as it is. Then you have minus 7.2 was this way, right? Fraction over here. So this is basically here minus 7 1 over 5 less than 7.8 is given as it is less than. Okay, so this and this are done. Then the next one we have here is 8 less than minus 9.1. Okay, so this is how you would arrange them in the order. Okay, we're talking about absolute values. Fine, are we clear so far? Okay, and now we are on the last part. Just few more questions and we are done. It says graph the original numbers on a number line. Okay, we have to put the original numbers. So we will consider the signs as well. We're not putting the absolute values over there. Okay, so let's get going with that. So what is our values? The negative highest is 9.1 and the positive highest is 8. Okay, so let's start. We'll need a bigger number line. I'll start from here. I will need more markings. Okay, so here we are. Let's start with minus 10, okay, because 9.1 is the highest that we have on the negative side, right? This is minus 10, minus 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Then we go positive side. The highest we have is 8, right? So we'll have to have until 8. 1, 2, 3, 4, 5, and 6, 7, 8. Perfect. Okay, I just did it dark so that I know this is 0. So let's start numbering it. 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. Okay, so 23 over 8 was 2.875, right? 2 is here and 3 is here, so 2.875. So 2.8, so I'll take 8 and 75, right? So I'll mark somewhere between 8 and 9. Okay, so this is 23 over 8. So first one is done, then the second one is 0. Done, 2 are done. Then we have minus 7, 1 over 5, right? This fraction which was minus 7.2. So here we are between 7 and 8, right? So 7, 2. So we'll take 2 units here. And this is minus 7.2. We'll write the fraction here, okay? So minus 7, 1 over 5, right? Next you have is 6. These are easy numbers to do, right? When numbers are given directly. So this is 6. Then you have minus 17 over 4, which resulted into 4.25. So let's go between 4 and 5 here, okay? And it says 4.25, right? So we'll mark somewhere between 2 and 3, okay? This is minus 17 over 4, right? Then you have 8. Thank you. Much easier to mark, right? Then 7.8. So between 7 and 8 here, we'll go 8 points from here, and this is the 8 point here. So which is 7.8, okay? And then you have minus 9.1. So 9 is here and 1 point here, right? So this is minus 9.1. So let's see whether we have all the 8 numbers. 1, 2, 3, 4, 5, 6, 7, and 8, right? This 8 is also there. Okay, so we have all these 8 numbers here. Which negative number in the list is furthest from 0? Which negative number, right? Furthest from the 0. 0 is here, most far, right? So this is negative number that's most far. So this is minus 9.1. That's it. If this is done, after this, answering all this is much easier. Any questions based on this number line, you can then do it, right? So plotting this is important. Plotting it right is important. And it says which positive number in the list is closest to 10. So the 10 would be somewhere here, right? We stopped at 8 because we didn't want more. But if you go here, it would be 9 and likewise, right? So this is the closest number. Positive number is 8. Okay, not 7.8 because it comes before, right? Which time is closest to minus 5 minutes? Minus 5. Okay, So you have negative here, this is after 7, and this one is between 5 and 4, right? So this one is the closest. So which time? It is minus 17 over 4. That's it. And the chapter is done. Okay, so these are simple things that you are asked in this chapter. If you want to revise, please go back to the first video which talks about the concepts. Understand them whenever you are stuck here. I've tried to recall the concepts every time. I tried making some mistakes that we would generally make so that we avoid in the exam, okay? If you have doubts, you can go back to that video. As I said, watch it, understand it. And if you still have doubts, you always have the comment section to comment and ask your queries. Okay, so that is it. And you can watch other videos for the other independent practice exercise and the concepts as well. Thank you very much. Enjoy your math. Remember, math is fun. Bye-bye.